And as networks become more distributed, virtualized, and software-driven, operational complexity continues to increase. This session explores how AIOps is being applied in network operations, that to shift from reactive troubleshooting towards predictive and proactive management. Joining this session are Frank Miller, Chief AI and Platforms Officer, that at Colt. Next to him is Ali Tizgadam. He's Chief Automation Architect, Technology Fellow at TELUS. Next to Ali is Ram Ramanathan. He's Vice President of Product, AI Automation and Cloud, that at Rakuten Communications. And on the end is Anshul Bhatt. He's Chief Product Officer, OSS Business Unit, that at Rakuten Symphony. And gentlemen, welcome.
Welcome to be here.
Thanks for being here, everybody. Made it on time. First session on the second day of the conference here. I know it's a challenge getting in, so we appreciate that. Ram, with Rakuten Communications, I'm going to start with you. And again, sort of setting the stage for this conversation today, talking about AIOps. What would you say is the biggest challenge with organizations adopting AIOps today?
Yeah, I think when you look at both fixed and mobile networks, what we're hearing from our customers are basically three areas of interest. And if you look at the network lifecycle, it kind of aligns with that from a day zero, day one to day end perspective. So what we're seeing, the first domain is day zero, day one, which is more network deployment related issues, automation issues. Day two to day end is more operational issues, and then kind of security goes across. So the key problems or challenges that we're seeing is from a deployment automation perspective, networks are getting complex to upgrade, to change, to monitor. So it's really how to automate with CI/CD pipelines, the day zero, day one kind of deployment automation. Then we get into once it's deployed, how do you keep the networks operational with the complexity, with the people leaving the workforce, things of that, those challenges, how do we kind of manage that? So AIOps is going to help in the near future with more of the operational techniques and resource optimizations and things of that sort. And the third domain is security, which kind of goes across day zero to day end, kind of keeping up to date on security patching, compliance, and so forth. And that's top of mind for most operators. So those are the three domains or challenges that we typically hear from customers.
Frank, from the operator's perspective, some of the challenges that you experience that can be solved by AIOps and the adoption of that.
Sure. I think actually the biggest challenge is going to be tied to the human factor and the responsible factor. So at the end of the day, you have to make sure you have a value proposition. You have to set up governance frameworks, right? You have to make sure that ownership is with the user groups. So it's a bottom up. It's really not a top down approach. So you make sure you have ownership in the organization with measurable value. That's the human side. Now, the technology side, as you brought up, is really interesting because there has to be, by personas, value for everybody. So at least as Colt, we have more of a traditional AI practice with the AI pipeline. We'll come to complex use cases, and I can talk about that later. There's another effort with the key SMEs where we're getting them enabled, like your finance folks and even our NetOps teams. We're giving them a safe place where they can build agentic frameworks, maybe some, machine learning that with no code, low code ecosystems. Then finally, there's AI for everybody. So it's fascinating. You have to build a pretty complex platform, vendor neutral, well-governed, secure data privacy. And finally, it's the management of AI, because even if you enable everybody, you have to have a responsible owner. If you build models, they drift, right? I mean, it's not a one-time effort. So it is a complicated effort, but at the end of the day, I think it's starting to pick up and demonstrate value.
Yeah. I wanted to get to reactive and proactive troubleshooting and network management with TELUS. But before I do that, Anshul, did you want to add anything to this?
Yeah, I think I totally agree with Ram and Frank. I think the challenges are all across people, process, tool ecosystem. I think Ram talked about the technology part. Frank talked about the process part of it, but also I think the organizational aspect. So for example, you can't simply expect a central organization that, okay, these are the AI guys and they will implement AI for everyone. I think there has to be a right organization structure where there is a hub and spoke kind of a model where you have the competency governed centrally, but at the same time, if you really want to execute, you gotta have the teams embedded into the day-to-day departments, like be it RAN, core, OSS, BSS, whatever domain of the network you're talking about. So I think the right org design is very important as well, apart from process and technology aspects that my colleagues touched upon. So, yeah.
Yeah, Ali with TELUS, we want to talk about the reactive troubleshooting, that shift to proactive network management, and how really predictive intelligence is playing a big part in that.
Well, historically, even if you look into standard bodies like TM Forum, Autonomous Networks Framework, or AIOps, we have been talking and we still talk about incident management and problem management, right? So incident management comes when there is an issue, and usually we have two types of closed loop, the fast closed loop and the slow closed loop. The fast closed loop is basically a remedy, a short-term fix that makes the service alive while we are trying to find the root cause, right? Mm-hmm. And then when we find the root cause analysis is done, then we have the longer closed loop that is basically solving the problem and making sure that this incident next time is not happening, right? Predictive analytics and what I would like to call anomaly prevention instead of anomaly detection enables us to merge these two, and instead of having incident and then doing problem management, we predict the incident to happen. And now, but there are many things that needs to come together in order to enable us to do it. One of the reasons that the AI initiatives in telco, unfortunately many of them are failing, is that there are many interdependencies between different domains, between control plane, data plane, services, and customer-facing parts that we don't consider. And in order for the predictive analytics to be successful, we have to have 360 data from all these domains coming. That's really, and that's what we are trying to do nowadays. We are trying to build a standard data platform that looks at data as products and enables this.
I mean, it's a good segue into the next question for Ram. Accurate AIOps for insights and automation, very important. What type of data and telemetry is really required to do that?
I think this is the most relevant question, I think, for this session. I feel data is the key, but the right type of data is the key, right? If you split the problem into MLOps and AIOps for a sec, it is about getting the right deterministic data for MLOps, things like stats, alarms, things we're used to as network operators, right? So that's key to get MLOps going in terms of predicting something just deterministically. But then as you get into AIOps, in the last couple of years, that is added on to MLOps by getting in non-deterministic data, logs that are plain English or other languages, right? Getting into RAGs, different kind of RAGs, whether it's carriers' internal databases, historical incident, databases, and so forth, and even human knowledge that's, tribal knowledge within the systems. How do we kind of bring that on top of MLOps, put on the AIOps infrastructure, and then get into more predictive and more closer to the root cause analysis that Dr. Ali was talking about? So that is really key in getting the data. Now, the right kind of data also needs to come at the right time. So it cannot be data lakes like we've done in the past, and we call it data swamps because people put data in, nobody uses the data, right? So it has to be real-time streaming data. As and when things happen, we have to start predicting operational issues, fraud issues, and so forth. It has to be real-time. So streaming of data, collection of data at the source is also key.
Anshul?
Yeah, I think, in terms of variety of data, there are a lot of, like Ram mentioned, logs and other stuff, but also I would like to touch upon the mechanism of how we collect data. I think it's important that we think through by first principles when it comes to applying AI. So for example, like telco industry is used to all these, KPIs or alarms with vendor-defined severity or vendor-defined formulae. And maybe those formulae were right, or the severities were right when the vendor tested that network product in their labs. But when it comes to a real production network, every telco network is different. So what we did in Rakuten is we took a step back, and instead of relying on the EMSs and the ready-made MIB files and KPI definitions, we just analyze the counters. And when you analyze the raw counters, and let AI give you the leading indicators or lagging indicators, and sort of like the behavior of the counters when something goes wrong, sort of gave us like an AI-defined KPI formula instead of a human-defined KPI. So that approach where we just ignored the human-defined definitions of severity and KPI formula and just took the raw counters, I think that really helped us to get the insights that the human-defined KPIs could never give us. So I think apart from just measuring different kinds of data sources, also instead of relying on EMSs, it really worked well for us when we forgot about EMSs, had our own collectors, extracted the raw metrics in real time, helped us to get more insights out of what we used to get from EMSs and legacy systems.
Yeah.
Yeah, I think it's pretty interesting because I think the value prop on, I'm going to call it the more traditional ML stuff, is actually pretty well understood. The cloud folks came up with message buses. I would like to state, though, that it's really important that when you build ML models to follow a feature parsimony. So that's why it's important to have really good data engineers. You don't need 1,000,000 by 1,000,000 features. If you can get the same accuracy with 1,000 by 1,000 features, go for it. You're going to save a lot of money and inference power. But I do think we stand on the border where, I know agentic's been overused. So Blueprint's been out for a while.
Yeah.
But there is value in agentic. So for instance, Colt here with Amplify, you'll see on top of our NAS stack. So we have our complete infrastructure abstracted as infrastructure as a service. You have a complete message bus and ETL framework. But you're going to actually see a working agentic framework that actually applies to policy from a predictive standpoint. So that's a demonstration you'll see with us in Orange with Amplify, where we have, let's call it a certain quality. Maybe it's a guarantee TTL, X, Y, and Z. Just pick the adjective. We have a closed loop predictive framework where we built an agentic stack on top of the NAS stack with data in motion. So it's really different. If you'd have gone back, 2 years, we'd have done like linear regression. You need a change, you have a policy, you go. I'm actually fascinated. We've actually done an experiment, as I said, where we stuck agentic by different network domains, fixed and mobile, a little deeper, and have actually kept the same experience for the customer. So it is a changing world.
Yeah. Ali, I wanted to ask you about machine learning models and implementing those into live network operations and maybe some lessons learned already in that space.
Sure. I think I'm going to start by commenting on the previous question that is tied to this one. So, another aspect that I would like to add to what all of our friends discuss here regarding the data is the adding of customer experience data. We have been the victim of silent failures for many, many years. And silent failures is the failures that customer detects before us. And why that happens? While we look at the KPIs and all of them at the network are healthy, 100% healthy, but still customer complains, there is a gap. And that gap is that hidden correlation between network events and the services that we have not detected. It's extremely important to include the customer experience in the data product and have it in the mix and inject it into the ML models to enable them to detect those hidden correlations. And that's tied to your question now. What lessons we learned? Model accuracy by itself is not enough. You have to make sure that you are detecting interdependencies between the domains, between different layers of your network, control plane, data plane, different layers that you have from business perspective you have defined in your network. And then you make sure that you enrich your model with those. Otherwise, you are just accelerating your failure. I'm always saying control loops can accelerate failure in your network if you are not doing wise.
Ram, anything to add?
No, I think I completely agree with Dr. Ali here. I think it's about getting data. We are focused on the network, but there is a lot of data outside the network. When you talk about the customer experience side, the marketing side of an organization, there's more data about subscribers, what they're facing, as opposed to the network, how it's behaving. So if there's a way to bring data together, I think that's going to be important as we go forward. Some of the experiences we've had, a couple of, just quickly in the interest of time, is really the solutions need to to be multi-vendor. We are really at a point where we're creating islands of automation, if you will. So how do we bring all these islands together? And how do we bring layers from layer 0 to 7 together? Because we are focused on troubleshooting at one layer without understanding that the symptom may be, or the root cause may be at another layer. And organizationally, we are not set up to look across layers. So how do we kind of bridge the gap, layer 0 to 7, left to right? And we have some use cases where we've gone from RAN to packet core to IMS and broadband data, stitching them together so we can look at that holistically to get to the root causes. So it's very critical that we look across the network, top to bottom, and then outside the network, tying up into NPS scores, customer experience domains, and so forth.
Anshul?
Yeah, I think in order to have like the effective AI strategy, of course, like having a good model is important, but also the metric that we want to focus on is the time to value. So, for example, a given data scientist might take like a few months to roll out a model in production if they are not provided with the right workbench. So what we did is we made the entire process easy, and especially the 70% of time which goes into data cleaning, massaging, getting the right data, or getting the right access to the metadata. So having the right metadata dictionary, having the right workbench to actually train and test your models, having a right evaluation framework, and then a pipeline to deploy the models. And I think Frank talked about MLOps and some of the important aspects that your job is not done if the model is deployed. It keeps drifting. There are errors, so you have to correct them. And so there is this whole day 2 aspect into AIOps as well, which needs to be considered. So obviously, like, model is an important part of it, but all these surrounding CI, CD, and DevOps work is also equally important, and it's necessary to get a right platform to be able to do that. And that's what we invested and focused on to create sort of our own AI workbench engine to really make it effective, reusable, and trackable.
Frank, I'll start with you on this one. Oh, did you want to respond?
Yeah, just really quick. One of the things that's missing from, I don't want to use the word legacy, but bear with me. A legacy OSS PSS framework is a service graph. So the challenge is when you actually build your model, correlation is not causation. The way you build causation is you have a service graph, right? So that's what's pretty interesting. When you build a service graph, at least in modern orchestration references, when you build that customer service by all the inventory components all tied together, you know who your customer is affected if this happens, is there, causation over here. The bigger challenge, like I said, are the passive components. So, going back and actually looking at your racks, your ports, your conduits, et cetera, I think is another, it's almost an open area that also has to be done, at least for infrastructure providers. Sorry.
No, absolutely.
Yeah.
I wanted to go down the line here. Anshul, I'll start with you, and again, go down here. Well, and my original question was predictive intelligence with AI-driven networks. Where would you anticipate the network to be in 3 to 5 years? But I'll change that. Predictive intelligence in the next couple of years. What would be what should we be discussing and focusing on at that point?
I think in order to really make the predictive AI useful, I think it's also important to talk about the action orchestration and sort of evolutionary workflows. So the difference between automation and autonomy is that like an autonomous network would learn from its feedback. And I think in order to be able to take actions autonomously, there has to be a universal definition for APIs, for network APIs, for action orchestration scripts or templates. So I think it's high time that we start standardizing or thinking about how do we, and I think we are doing part of it in Open RAN in form of RApps and RIC, but I think there has to be, or there is a need to have a general purpose standards to be able to implement action orchestration scripts in a way that's like, call it an RApp, call it a network app or whatever. But I think a lot of focus needs to happen to make a universal adapter or like at least a template so that AI can actually learn from the feedback or like by monitoring what people are implementing or what actions humans are taking and start autonomizing that. So I definitely see predictive AI going more towards action orchestration and level 3, level 4 autonomy across many more scenarios than the TM forum defined ones in the next couple of years.
Ram?
Yeah, I see the industry, the vendor community, the carriers growing in two different, kind of angles. One is data democratization in terms of not keeping data in silos, as we just discussed in terms of network data, customer data, field tech data. There's just too many different domains and silos. How do we bring them together for the common good, right? Just as an example, if there is with proactive maintenance, if you find something is going to happen, or with reactive, we can quickly get to a root cause, and we know there's an ETA of an hour or 2 hours to fix the issue. Is there a way to connect to the customer support side of the business and send proactive emails or SMSs or whatever to the customers to keep them at bay, so they're not calling and flooding the contact centers? So that way, the rest of the organization is aligned with what's going on in the network. So it's really connecting the network to the rest of the stakeholders within the company. So I think that's going to grow more and more as we look forward in the next 2 to 3 years. The second aspect is, I think Frank talked about this, is in terms of workflows, low code, no code, so we can obviously, look at models and complex things. But if it's not taken to the masses in terms of the NOC teams and so forth, it's just going to be, lying there as nobody's going to use that. So make it easier to use, low code, no code, create your own workflows. It's not just the vendors creating workflows, but the carriers doing it themselves, right? To enable that kind of low code, no code capabilities to define workflows and do more of them. We have some customers doing millions of workflows in a year. How do we get to 10 million, 20 million workflows and things of that sort? I think that's the other angle that's going to grow from here.
Sure. I want to take it from another angle. In telco, we used to have services that are long-lived, such as mobility, data, internet. We have loyal customers as long as we give them reliable service, right? But the world is changing. We have introduced more short-lived dynamic services such as bandwidth calendaring, for example. But the most important revolution that is happening nowadays is the emergence of AI agents that are basically they reason and they make their own decisions. So that completely changed the spectrum. Because so far, we have been dealing all these automations, everything that we have been doing has been based on the assumption the logic is owned by human, right? Now, when we think about all of this, and I want to map it to operations and what needs to happen in next 3 to 5 years, the first thing is that if you ask our operations team, and I have done that, from 10 people I have asked, 9 of them were telling me that what they need is not finding the issue. What they need is to find what is the impact of that issue or event in the services, right? So that brings me to one of the efforts that we have to build a causal ontology graph, which is related to the service graph that we mentioned. The causal ontology graph that gives us that hidden correlation. And we are investing a lot on that, because as soon as you know what the impact radius is, then your autonomous network operations agents can easily create guardrails. And that brings me to the second point I wanted to mention. There is another radical difference in near future. We have checklists everywhere, maps, and basically based on those checklists, we check if what we do is correct or not, right? And why do we have checklists? Because we know what the expected outcome and what the input is. But as soon as AI agents with their own logic and reasoning come, we don't know that yet. So then while the checklists are still important in up to level 3 of autonomous networks framework, at least in TM Forum sense, when it goes to higher layer, we can't have checklists because we don't know what the decision will be for the AI agents, and that will be converted to guardrails. So we have to be very carefully defining, deploying, and managing the guardrails. And that's what I think we should do.
Frank?
Yeah, I think we have to stop thinking like telecom, right? We have to think like software operators if we're going to get the benefits of a software operating model. So a case in point, if you do have your entire infrastructure as API resource abstracts, that's great, because now you can apply CI/CD pipelines, right? So a CI/CD pipeline is done in a digital twin in the future of your network state. So there's a lot of growth we have to do at the end of the day. The network becomes a source of truth in inventory, right? That's number one. So sorry, we've been doing this for about 7 years now at Colt. We have a complete north-south NAS stack. Everything is automated. We talk to the network. Yes, there's integration to, now we have one legacy inventory operator. That won't be there forever. But again, we're on the road from, this is like building software. You don't build your product and then dump it to testing that takes 12 months. You actually test during the process. So source of truth is the network. Then you can use CI/CD pipelines if you have a native digital twin. But the last thing is, tied to what you talked about, agents. So we've been experimenting with agents because, business process workflows, sorry, that's just way too much work. So like you said, within the boundaries of giving guardrails, trying to manage agents across our different domains for, automation tasks. You'll see another demonstration. We had a hackathon with Microsoft with our pricing folks for our most complicated enterprise deals. Very complicated. I mean, you know how this works, right? You got a $50 million deal. A couple weeks later, everybody agrees, your bombs come out. It took us about a week of training. We built 4 agents, product agents, kind of a correlation agent, and then we built like an audit agent. Came out about 97 to 98% accurate. Yeah, we ran it, back and forward. I'm always worried about overfit, but it's not ML, right, at the end of the day. So it's a little different. So even for me, I was a skeptic until we actually did this. So we took what would be a very complex, long, laborious process that IT would manage. So I think we got that sorted. Now we're going to turn and apply that to service delivery, which we have a lot of automated stuff, but still at the end of the day, you talk to the customer and have all these other things, and you got to drop a fiber and all this stuff. So we're going to move to that next. So but back to you, what we stated, we have to empower your department. So we're having we got them in the hackathon, and they said, oh, we can do this. This was like a low-code experience. Now we're going to go to the service delivery team and say, let's come together, see what we can do in 2 weeks. We'll keep on doing 2-week sprints in the art of the possible.
Well, the title of this session was AIOps, or is AIOps, Predictive Intelligence for Network Operations. I'm happy to have everybody on this discussion. I'm sure we'll see everybody rather soon later in the year, maybe at TM Forum. Angela with Rakuten Symphony, thanks for your time.
Thank you, Abhi.
Ram with Ribbon Communications, thanks for your time and also supporting this session.
Thank you as always.
Ali with TELUS, thanks for being on with us again.
Thanks for having me.
Absolutely. And Frank with Colt, it's always a pleasure to talk to you.
No problem. Glad to be here.
All right, appreciate it. Talk soon.